what do I have behind me? Oh, you know what gets me most excited about these math problems? Word problems. Here we go. Let's read it. We got a full-on paragraph. Let's see what it's asking. You are comparing prices of two different sized jars of marshmallow sauce. Ooh, yummy. The 15-ounce jar costs $3.20. The 24-ounce jar costs $4.89. Which jar is the better value or the better buy? We're going to round each calculation to the nearest cent. Okay, so this is actually a very applicable word problem. I do this all the time when I go out food shopping. We're going to use unit rates because if we can compare each jar's cost per ounce, we'll know which one is more or less per ounce. And a better value would be less money per ounce. So let's do the 15-ounce jar first. Let's calculate that as a unit rate. To do that, I'm going to do dollars per ounces. It makes more sense to me because then we're making a unit rate in terms of ounces, right? So dollars per ounces would be $3.20 per 15 ounces. And what we'll do with that is we'll calculate the unit rate. So I divide the numerator by the denominator, and what I get is, as a fraction, no, not as a fraction, but as a decimal, we're going to get 0.213. And your calculator will return something where it's 0.213333333. Rounding to the nearest cent, that would be approximately $0.21. I'll put the units there, right? Or 21 cents per 1 ounce. Okay, so we've got the unit rate now of the 15-ounce jar. Now let's find the unit rate of the 24-ounce jar. So that would be in dollars, $24, not $24. That'd be some expensive marshmallow sauce. Better have some diamonds up in there. We've got $4.89 per 24 ounces. Although I think having diamonds in marshmallow sauce, probably not good for your teeth, just a thought. Anyway, we've got the dollars per the ounces. When we divide that in a calculator, we're going to get the answer of 0.203. So what the heck does that mean? Well, that means that when we round to the nearest cent, we've got a 3 here, so that's going to be 20 cents or $0.2. So 20 cents can be written this way, 0.20 cents per 1 ounce. So if we compare the two values that we got here, the 21 cents per ounce and the 20 cents per ounce, it is clear that this amount is less per ounce than this amount. So the 24-ounce jar is the better value. Awesome, awesome stuff. A cool word problem because, well, it's something that I used just last week when I went to the supermarket. You might be thinking, lame, Mr. Grodin. I'm thinking, wicked cool use of math. And here we have a second type of unit rate word problem. Let's jump right into it. It'll be a quick one, and it's one of those kinds of problems where you might have another way of doing things mathematically to get to your answer, and that's just fine. Let's roll into it. You were earning $9 per 1 hour working on a dairy farm. So a dairy farm, for those of you that don't know, is a place where they have cows, and those cows give milk. Dairy farm. How much money will you earn in 7 hours? Okay, well, one way of doing this is you can just mentally think of the math and think, well, I've got $9 for 1 hour and I work 7 of those $9 units. So that would be 7 times 9 or 9 times 7, and that would be $63. So that's the mental math approach. I'm going to show you another way to support this, and it's the type of work that some teachers demand from you. So just in case you need it, here it is. We see that we have a unit rate right here in the problem, $9 per 1 hour. So I'm going to write that out, $9, make that decimal a little bigger, per 1 hour. Now essentially what we want to do is we want to find another rate that is equivalent to this over 7 hours. So it's kind of like we're undoing the unit rate. Well, so this is going to need to be equal to something per 7 hours. Right, we know that we need to get to 7 hours because we want to know how much money will be earned in 7 hours. How do we get to that 7 hours? Well, I would multiply the numerator. I'll erase that to give it a little more room. I would multiply the numerator and denominator by 7 because 7 times 1 gives me the 7 hours that I want. And we know that whatever I do to a denominator, if I do it to the numerator, it gives us an equivalent fraction, and in this case, an equivalent rate. 7 times 9 is equal to $63. And so the answer is we will earn $63 in 7 hours. Cool stuff, y'all.